We have cumulative countdown, which I guess we're going to be doing countdowns across multiple different strings. I guess for every string, I don't know. What is the purpose of this estimate? I think it's something about calculating the volume of each staircases. We have to put the intern somewhere. For each thing in the inbox, outbox, the sum of itself plus all numbers down to 0. For example, if inbox is 3, outbox should be 6. Okay, so we're just doing the summation formula. I wonder if it would be possible to do the closed form summation that you learn in calculus, but I think that might be way more expensive to compute, so we're not going to worry about that right now. It's going to try to center my image a little bit again. That looks good. Okay, sorry for bearing with me for a second there. That was not what I meant to say, but that sounded kind of amusing anyway. Alright, so, without any further ado, let's try to remember what the hell I'm supposed to do in this game. I guess the very first thing is I need to inbox my value. And then I need to... Well, this is just adding up a bunch of loops until it gets down to 0. So that's actually pretty straightforward. So we're just gonna... We have our 0 here, so the very first thing we need to do, instead of inboxing, we're gonna need to copy from our 5, which we'll just name 0. And then we're gonna copy that into our register 1 here, which we'll call the sum... This is basically I for our loop, and then we need our sum. Alright, so without any further ado, let's get started. So we inbox 4, and we copy that to I, and then I guess we don't need to copy 0 in, because we should just start from sum. So we don't actually need 0 at all. So let's get rid of that right out the gate. And then what do I need to do? I need to check the state of I. And if it's 0, then I don't do any more addition. And then I will outbox from sum. So copy from sum, outbox, jump, back to the start of our function. Alright, what is copy to I, then? I guess I don't need copy to I. I don't know what I was doing there. But that's fine. Okay, this looks good. And then I need we need to add whatever we're currently holding, which has been copied to things, to sum. And then when we jump back, we'll need to do a copy from I. Okay, so we add what we're currently holding to sum. And that's all we do. I think this is correct. Let's try running this and see what the hell happens. So we put down 4, we put it into I, and we put it into sum. It does 4. We add 4 to it. I did this way wrong, and I don't even know what the hell's going on. Yeah, a little bit brain isn't there at all right now. So after we add to sum, we're gonna subtract something. We're gonna subtract from I. We're gonna subtract from I first, and then add it to sum. So put down 4, bump it. We didn't really need to do that apparently. And then I need to I need to copy what I'm holding into sum. That's the other thing I need to do. So let's skip one of these copy from instructions here and just do bump on this outside area. This should do it. And that way we could, because bumping will automatically return what we bump the value to. So we might as well take advantage of that. And this looks pretty good. This looks really good actually. So we add 0 to 10, or no, we just outbox it straight away. Okay, that was perfect. I mean, perfect in the sense of I did it a really, really, really dumb way the first time I did it. But at any rate, it seems to work out okay. Alright, so I'm going to go ahead and just speed this along. There's 21. Oh. There's an issue. I'm in an infinite loop. Okay, that's fine. That's probably why this is putting in here in the first place. So if I jump if 0, if I bump first and then jump if 0, then that's bad. Because if it's negative, then I also will need to do like a check basically. So if I can't quite optimize this, I can do another check, which is a little bit, it's inefficient to do another check and then jump out if it's negative. But then the other way to do it is to do a copy from and then a bump on the inside of the thing, which this way also works, but we're doing an extra copy, so we're kind of coming out behind no matter what way I approach it. Let's do the copy from statement first, and then do that. So we grab 2, bump 1, then we grab 1, we check if that's 0, it's not 0, so we don't add anything to it. We pull out 0, that is... Yeah, okay, so this is correct. Again, like, either way I'm doing it, there's, like, not really a good approach that fully eliminates not having to do, like, an extra bit of work. I don't like that so much, so maybe there's probably a different way of optimizing this than what I've done. On the other hand, the size challenge is correct. And, yeah, the speed challenge is way off base because of that extra copying and stuff. I'm not going to worry about this, as always. Let's just enjoy ourselves a little bit of a Midnight Petroleum for right now, instead of having to worry too much. Huh. A little bleak, maybe? Huh. It's a robot. Or something. Okay, that's horrifying. So there's, like... I saw this in one of the other cutscenes where it was saying something like there's a bunch of robots in the outskirts of the city, they're coming in to kick our asses. I guess there they are, huh? And I guess this is also the final chapter. Well, nope, there's where's Carol? So there's 3 or 4 levels, then it's the final chapter. Okay, my mistake. The point is, Midnight Petroleum, I guess that has something to do with oil. Sabbatical Beach Paradise. I'm just looking through all the names of the cutscenes to see if there's anything weird in them. Not really. They're weird. I mean, the content of them is weird, but the names themselves are okay, I guess. Big changes are coming, but I see you already know that. Huh, my hair's different now. Yes, you can now access slots on the floor indirectly. What does that mean? You will see. It's going to change everything. Imagine each thing in the inbox is an address, and each address refers to a tile 0 through 9 on the floor. Your task for each address in the inbox, pick up the letter at that address and outbox it. So, let's see, you can now access tile on the floor and directly observe this example to see how it works compared to what you've been doing so far. Okay, so copy from 12. This goes to the absolute address of 8. And then copy from that 12 is 12 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Huh? Yeah, pointers, yay. Yeah, there's a... It's sort of... It's not really a pointer, it's just relative addressing. So it's kind of funny that they have this bracket notation, because that's how it's done in, like, x86 and stuff like that. I digress. I don't quite see how this math works, because I don't know what it's relative to. So, like, if I copy from 0, what is this? Is this going to be address 12 then? Like, it's... Wait, what the hell? How is it based off of this? Copy from... I don't understand what this means. Like, what it's relative to. Each address refers to a tile 0 through 9 on the floor. I don't know what it's asking, what it's relative to. You can access them indirectly. Oh, the value copied tile is the address. You're right. Okay. Yeah, that's correct. This is kind of like pointers. You're right. So, in register 12 is a tile containing 8. So when we do indirect addressing mode, we copy in yeah, that's how this works. Okay, then we go to address 8 in our or register 8 or address 8 or however you want to think about it. Anyway, so what is our goal here? Imagine each thing in the inbox is an address. For each address in the inbox, pick up that letter at the address and outbox it. So this is actually really straightforward. So we just inbox this, and I don't think I have any mods on right now. So Purple, you're being promoted. Kill that guy. I mean, not in real life, but do some sort of, I don't know, make fun of his mom or something. All right, what do I want to do? So for this address, for 2, we look up what's in address 2, so we should return A as a result. So we need to, when we inbox this, we just need to store it in a register. So we'll store it in 8. And then when we do that, we need to copy from what's in 8, but we need to copy from what's in 8 relatively. So not in 8, what's in 12 relatively. I'm sorry, I was reading 8. So anyway, we'll look at this. We'll from 12 relative, and then outbox that, and then we just loop back to the start. So I wonder if this is going to spell out a word. I feel like it might. We have A, J. This isn't looking so promising. A, J, E. That A, J, E, J. Yeah, this is not looking promising or whatever. Okay, yeah, Purple got mod just because there's a spammy spam. Okay, so this did it just fine. Let's load. Let's DJ. Perfect word. Yay, thank you. Year 29. Wow, I've been working in this office forever, huh? I think I did that optimally as well. Yep, cool. That's actually a really straightforward level because that's just a damn tutorial, basically. So if I don't get that optimally, that's a little bit of a bad thing. Special covert assignment. Management is requesting strings from the floor. Let's just process the strings and not read or discuss what they say. It'd be impolite to read messages intended for someone else. And verboten. Each thing in the inbox is an address of a tile on the floor. For each address provided in the inbox, outbox the requested item from the floor and all following items from the floor until you reach a 0. Okay. So this is like basically like a cipher. Bird isn't even 40 years old. Are you clairvoyant? Oh, jeez. I thought you were talking about my character in the game. No, you were just bullshitting. Alright, so we inbox with... Okay, let's see an example of our input and output. If your inbox is 7, your outbox should be tar. So we look at... If we're in 7, we go to T. A, R, 0. Ah! I see. So... The way this works is that this is a array of strings, basically. So G, E, T, that's a null value, and then we stop. Okay, so we need to grab 4. The result of this one will be T, H, and then we stop. We're going to copy that to 24, which we'll name a meh face. And then we... copy from our 4 here. We copy from this. We copy from meh indirectly. So that gets our T. And then we outbox that. And then we need to check when this is 0. Oh no, we just bump it and then... Right, okay, so this just starts our loop, basically. And then we will... As long as nothing comes up as 24 in our domain, this should be just fine. Alright, so the idea is, from this point onward, we just go to the right linearly, picking stuff up. Alright. So this enters a loop. And our loop condition is if we're currently holding a 0. So we're going to need to jump if 0, which will jump us back to the start of our function. Otherwise, we jump to here, something like that. Okay, we'll not worry about our jumps just quite yet. So we have our this will grab T for us, and then instead of outboxing it, we jump if 0 somewhere. Otherwise, if it's not 0, then we outbox what we're holding, and then we need to bump that value that we're holding in our meh, and then we need to copy from meh indirectly. So that will increase whatever was being stored in here. So if a 4 was stored in here, we would do 5, and then so on and so forth. And then if we do that, we just jump back to this point. So we can get rid of one copy from it and just do it this way. So if we jump if 0 back to here, I think this does it. It's nice to have a break from the very difficult stages. Yeah, it really is. Okay, let's see what happens. We put 4 in our address. We grab T, we outbox it. We bump 4, copy to get H. Throw it in there. We bump 6, that's a 0. We test if that's 0, and we don't do anything with it. Okay, this will do it. So let's see what the tar... The target... Oh. The target... Come on. Okay, this is gonna... I'm gonna read this all out. The target X... The target XX? What the hell is that? The target XX is... awake. And then we throw that one away. What's the next word? Awake X... T... A... X-tac? Ah, crap. I've lost track of what the hell this thing is saying. This... X? The XX is a line break? Yeah, that actually could make more sense. Okay. Maximo 1112 says 3 sort gave you nightmares. I don't blame you. I mean, I know what I need to do with 3 sort. I just need to implement a comparison tree. I just don't want to do it. That does not sound interesting to me right now. That's going to be a humongous puzzle.